Welcome to the oscilloscope tutorial. So today we're going to be navigating through the oscilloscope. First, let's actually start with the window. So basically this is the window that you're going to see once you start up the oscilloscope, kind of defining some areas. First, you have this grid where the signal is going to be showing. Then you have this menu that is going to give you some details depending on what kind of setting or what kind of menu you are on. The first thing that I want to take the time to do is to actually define these squares as what I'm going to call the unit squares or the unit rectangles, to be more precise. These unit rectangles are a way for us to take manual measurements of signals, and its units are going to be defined by these numbers up here. So you see 50 millivolts for channel 1 and 5 millivolts for channel 2. So that means that in the y-axis, these squares or these rectangles are going to be 50 millivolts for channel 1 and 5 millivolts for channel 2. On the time axis, you're actually going to notice that this unit here is 50 milliseconds. So what that is indicating is that in the x-axis, this is 50 milliseconds. And that's going to be important when we're thinking about the frequency of the signals that we're analyzing and whether the window is big enough for us to see that frequency. We're going to be working with a lot of signals with different frequencies, so it's very important to get familiarized with this. The other thing we have here is in a default channel, you're going to have the two channels defined as AC, that is alternating current, and in most cases, not all, but in most cases, the probe needs to be set to 1-to-1, 1 column 1 and 1 column 1. What that means is that the signal that is coming in is going to output in the oscilloscope exactly as it's coming out. And then under here, we're actually going to turn on some things. You don't have to worry too much about this just yet. But we're actually going to turn some measurements down here that are going to show up. But let's actually talk about navigation. So if I press channel 1, you'll notice that the light turns orange. The channel menu pops up. You're not going to necessarily need to navigate this channel, but just showing you what it's about. Now I am changing the channel 1, and the horizontal knobs are going to be, as the symbols show here, you can see that this is going to stretch out the signal in the x-axis, meaning that it's going to make the time, as you can see in the top here, it's going to make the time bigger or smaller. This other knob is actually going to change the trigger, which is this little arrow up here that you can see, to be a little bit delayed or forward in time. But honestly, I typically just push it to set it up. One thing about these buttons, particularly this big one, is that if you read over here in the oscilloscope, you might see that it says push fine. What that allows us to do is that if I want to manipulate the time a little bit more gradually, I can push it. In this lab, we're not going to need that precision. So honestly, most of the cases, we actually want to turn off that setting. But it could be that someone bumped it by accident and turned it on. So it's important to know how to turn it on and off, because we're going to be wanting to move quickly. So that is the horizontal manipulation. In the same vein, we have the vertical manipulation. And again, the oscilloscope has a lot of keywords and symbols that show you what each knob does. So in the case of the vertical, you see that there is this bigger amplitude and smaller amplitude. What that's going to do is that it's actually going to increase the Y amplitude shown in the signal. So a very important clarification is the fact that this is not changing the signal, this is just zooming in or out to show how big the squares are. So remember, in this case, you are getting the square to be smaller, which means that I'm going to be seeing more details or more signal. Similar to the horizontal smaller knob, the vertical smaller knob is used to just zero the signal or move it up or down if you prefer to see it in a different position. So that is the vertical manipulation. These two pairs of knobs are going to be your best friends, and you should familiarize yourself with them and be comfortable using them, because sometimes, let's say your signal, it's not visible, you might want to be able to find it and manipulate it in a way that you can actually get back to the signal that you were recording. Now let's actually get into measurements. So the measurements are going to be what is going to allow us to take measurements of our signals. So the first detail on the measurement menu is going to be the source, which channel we're taking the measurement, the type, which is going to be what type of measurement we're taking, this button, as well as pushing this little knob here, will select that particular measurement. And then there's some settings here, which we rarely get into, but I might go in just because I want to be exhaustive. So let's say that I want to actually take the peak to peak of this channel 1 signal. So the peak to peak means peak to valley of a sine wave, the range of the signal. This is the quote unquote amplitude measurement that we're going to be taking in this lab. So if I go ahead and click add measurement, you're going to see that this signal right now is 2.7 millivolts. And if I kind of let go of the probe, it goes up to 9, 10 millivolts. Let's say that I also want to add for channel 1 the frequency. So I can go ahead and use the knob to scroll over until I get the frequency, and I can press this button to add it. So right now we have a 60 hertz noise signal, which you should be familiar with that 60 noise. That is power hum that the probe is capturing. So we can actually see the power hum at 8 millivolts and 60 hertz. So all the types of measurements that you're going to need for the labs are going to be in here. We're not going to use that many of them. We're going to use phase, we're going to use frequency, we're going to use amplitude. So you should feel familiar with these kind of measurements. Now to change the source, let's say we actually want to also take the measurement of channel 2. I can press channel 2. Let's say I want to also add a peak to peak, which is already selected. And now I have the peak to peak for channel 1. And I have the peak to peak for channel 2. And channel 2 is not very active, so I shouldn't be seeing a lot of information. There's no probe in channel 2. But important, for these measurements to work, you actually need to see the signal. So I'm going to go ahead and turn off channel 2 and see that this peak to peak wave, I can see it, and it gives me a 9.8. If I zoom out way, way away, but I cannot see the signal, notice how this is telling me, oh, the signal is 30 millivolts. But that's not quite true. We actually need to make sure that the signal is visible for the measurement to take place. That goes for peak to peak, that goes for frequency, or any other measurement that you're taking. So that is adding measurements. A lot of these other buttons we're actually not going to play with. So the last button I'm going to show you is kind of a bonus menu, is the trigger menu. So let's say we have a signal of this amplitude, and I want the signal to freeze, so it's actually visible in my oscilloscope. This is where the trigger menu becomes useful. So if I click trigger down here, I want to change the coupling to AC because my signal is AC. The trigger type, I always like to check. It's detecting an edge. What that means is that it's detecting when the signal goes from down to up. I check the source, whether it is channel 1 or channel 2. We're going to want to keep source 1 for this particular lab, and we'll explain why in a second. And then the slope is going to be down to up. I can change that to falling or alternating or either, but in this case, this is the default, so it's fine if we keep it that way. The mode, we want to keep it at auto and then not bother too much. So if I twist this knob here, What that's going to say is that if that's going to move the trigger menu, this might not be a good signal to demonstrate that with. That's going to fix. So I typically just push it, and that allows you to frame this signal. So now that is the trigger menu. First thing we need to do for the probe is to actually compensate it. So you'll notice that all of these oscilloscopes have these demo probe compensation knobs here. What we're actually going to do is magic trick, hold, you see this hook, we're going to hook that into here, and we're going to then take the alligator clip and hook down there. So I have my two connections. Now, I see a window that is full yellow, all kind of chaotic and messy. So I need to get my two best friends here, the horizontal and vertical knobs, and manipulate them. I'm gonna go ahead and start with amplitude. And I'm just gonna make sure that I get the signal within the window. And then I'm going to play with the horizontal knob to fix the signal. So in this case, this square wave that the oscilloscope is providing, I see it as a full square wave. Some of these probes have amplification, have some other components inside of them that can get out of whack, and then this square wave not look appropriate. So if that is the case, we actually take a little screwdriver that we're going to give you into this little hole here to adjust the signal. So this probe is actually compensated. So I'm actually going to mess it up so you can see what non-compensated probe looks like. So you can actually have this peak going down, or the opposite, this peak coming up, or this curve coming up. What we actually want to make sure is that we set the window to be as square as possible. It doesn't have to be surgical, but it has to be straight in order for us to understand that, hey, my oscilloscope is giving me a square wave, and then I see a square wave. That means that all the components inside of here are calibrated, so I get exactly what I need to get, and I don't get any other type of noise. So that pretty much concludes the oscilloscope tutorial. If you have any questions, don't hesitate to ask us, and see you in the lab.